everyone, welcome back to another episode of Chemistry Train. So today we'll be going through different intermolecular forces stations. So hop on and let's start learning.
Hello everyone, welcome to the Dipole-Dipole station. Before we begin, let me first explain to you what dipole-dipole forces are. Dipole-dipole forces are attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. For you to be able to understand better, I will be creating a model to show how dipole-dipole forces and interactions work. In creating the model, I will be using styroballs, paint brushes, and barbecue sticks. Second ball. Hey, no. Last ball. Now we stick it in. This is how it looks when you're done. So these are two hydrogen fluoride molecules displaying dipole-dipole interaction. The relatively positive end of a polar molecule will attract the relatively negative end of another hydrogen fluoride molecule. So the relatively negative chlorine atom is attracted to the relatively positive hydrogen atom. The interaction between the two dipoles is an attraction rather than a full bond because no electrons are shared between the two molecules.
Hi, welcome to Ion Dipole Station. But first, what is an ion dipole force? An ion dipole force is an attractive force that results from an electrostatic attraction between an ion and a neutral molecule that has a dipole. You understand? If not, I will help you. I will create a model that shows how ion dipole force works by using styroballs, paints, and a paintbrush. Welcome back to the ion dipole station. So, this is the final model for the ion dipole force. So this is the oxygen, hydrogen, sodium, and the chloride. The positive sodium ion will be attracted to the slightly negative oxygen atoms in the water molecule, while the negative chloride ion will be attracted to the slightly positive hydrogen atoms. These intermolecular forces weaken the ionic bonds between the sodium and the chloride ions so that the sodium chloride will dissolve in the water.
Hello everyone, welcome to the hydrogen bond station. But before we begin with our model, let us first define what is a hydrogen bond. So a hydrogen bond is a special type of dipole-dipole attraction or force. And I'm sure that you already know what a dipole-dipole attraction or force is. So what truly makes a hydrogen bond special is the presence of hydrogen itself, which is strongly bonded to electronegative atoms or highly electronegative atoms. We will be using ammonia, which is a common bleaching agent, and water as an example. So we will find out if the intermolecular attraction or force present in ammonia and water is a hydrogen bond. So we will be using styrofoam balls for the atomic model. We will be then decorating the styrofoam balls or the atoms with paint and paintbrushes. And we will also be using barbecue sticks to represent the bond between the molecules. So our model is already done. On my left, you will see the ammonia molecule or NH3. On my right, you will see the water molecule or H2O. And on the middle, you will see that there is a hydrogen bond formed. This is between the oxygen atom of H2O and the hydrogen atom of NH3, which is ammonia. The negative electrons of oxygen is attracted to the positive protons of hydrogen. That is why there is a hydrogen bond formed.
Welcome to London Dispersion Station. London dispersion force is also called as van der Waals forces, which is first identified by Fritz London. London dispersion forces are weak and attractive intermolecular forces between particles. I'm going to make a 3D model to show you London dispersion forces. The materials that I will be needing in creating the model is paintbrush, styroballs, and of course paint, and also barbecue stick. So this is the final output for the London dispersion forces. So we have two helium atoms and they have two protons on the inside. Let's just pretend that there's a proton inside this one and two electrons on the outside. So if you move them close together, the electrons are going to migrate. The electrons on the outside of one helium are going to be attracted to the protons on the inside of that other helium. There will be repulsion between those electrons on the outside. So simply, London dispersion is the connection between these two helium atoms.